Welcome back to Stewart Science. We're starting a new topic today on motion. We're looking at how things move. And all motion kind of starts with this idea that motion is relative. And that's kind of a strange word, relative. It just means comparative. You have to have a point in space to compare all your other positions to. In math class, you have a coordinate grid, and usually on that coordinate grid, there's a spot in the middle called the origin, which is 0, 0. That's the benchmark that all other points are compared to. We need the same thing in real motion. If we're going to describe how a car is moving, we're going to need to give it a reference point, a point in space that you measure all the positions to. So usually in races, that's the starting line. You're measuring how far away from the starting line you are. If you're going to run a 100-meter sprint, the finish line is going to be 100 meters from that starting line. So even in athletics, there's always a reference point. Or I'm a big football fan. The goal line is usually the reference point. All the yard line markers are compared to how far you have to go to get to the goal line. So let me give you another example of this. Like I said, if you have a car, usually the starting point of that car is going to be your frame of reference. So if I make this car move, the only way you can tell that it's moved is because it's not in the same place compared to that X that it was to start. It's gotten further away. It's increased that measurement from 0 to something. It's further away now compared to that red X. Now, if I bring in another object, let's say a stop sign, as the car moves, it gets closer to the stop sign and further from the X. So in this case, the perspective matters. If you have a friend who's standing on the X, you're going to be getting further away from that friend. You're leaving the friend. But if you have a friend that's at the stop sign, you're going closer to them. Maybe you're picking them up. So the frame of reference matters. In one case, if your friend is here, you're going away. If your friend is here, you're going toward. Here's another example. I love me some Chipotle. So if I were driving my car to Chipotle, my position compared to the stop sign is getting further. It's getting bigger. That measurement of how far away I am is going up over time. And my measurement of how far away I am compared to Chipotle is going down over time. This distance is shrinking, and this distance is growing. And so a lot of times what we'll do is we'll put these things on a graph. And so I have a couple graphs drawn here. We'll put position, which is a measurement of how far, on the y-axis versus time on the x. So the left graph, this one right here, we'll say that's compared to the stop sign. In this case, my car is getting further away. And this graph, my position is compared to Chipotle, that position is decreasing over time. So in one case, they see my numbers going up, which that's this one. The numbers are going up because I'm getting further from the stop sign. In this case, my numbers are going down because I'm getting closer to Chipotle. I do want to point out one more thing before I sign off. These graphs don't start or end at 0. Because in the way I had the picture drawn, in the first case, the car started a little bit ahead of the stop sign. It didn't start at the stop sign. That's what it would be if it was 0. And in the last case, this graph over here on the right, it doesn't end at 0 because if it did, then I would literally be crashing into Chipotle. When I parked my car, there's still a little space left between my car and the Chipotle building. So my car hasn't come into contact where that measurement is 0. There's a question I ask my students every year to bring this idea full circle. Are you moving right now? I ask my students that question, and they will usually tear each other apart for a whole class period. Because the question doesn't say, what the frame of reference is. Compared to all the things in the classroom or all the things in the room that you're in right now watching this video, you aren't moving compared to those things. Your distance from them is staying the same. But the Earth is spinning and the Earth is moving around the sun, and the sun is moving through the Milky Way and the Milky Way is rotating too. There's so many other ways that you are moving when you look outside the classroom. So if your frame of reference is anything immediately around you, you are not moving. If your frame of reference is anything else, if you zoom out and look at the Earth as a whole, you're moving very, very fast right now. So the answer to the question, are you moving, is compared to what? I'm Mr. Stewart. As always, keep learning, no matter what.